Welcome back to Within Tolerance, a podcast for machinists by machinists. I'm your host, Dylan Jackson, and this week I am joined by Jeff Tiedeken again, Yetiman, as you may know him. Thank you for coming back, Jeff. I appreciate it.
Yep.
And if you want to hear his backstory, go all the way back to episode 48. Peyton and I dived into his backstory. We talked to you back then. But this episode, we got a bunch of listener questions, and, a ton has happened in, almost a year since we talked last.
Yeah, you guys have done a lot of episodes. Super awesome to see that also. And it's crazy to think that you're at this many now. You said 48, and I was like, whoa, that's a lot of episodes. That's awesome.
Yeah, thanks. Yeah, I can't remember who I was talking to the other day. They're like, man, I keep trying to get caught up, and then you keep releasing new episodes. And I'm like, well, it is a weekly show.
It's awesome.
Yeah.
Cool.
So, we can jump into questions later, but what's been going on in your life? We've got a ton of questions about your projects, but what's the newest, greatest thing in your life?
Just complete madness as usual. Just pretty much transitioning. I'm trying to adjust my business a little bit for this next year. I've noticed a lot of changes happening in the industry, and I'm sure everyone knows everything about their little pockets of things. But one of the craziest things that's been happening out here, and it's probably same as everyone, it's both material shortages and also just getting people to actually want to do the work. And so I've kind of started to transition my business, and it's been super interesting because it's trying something new, but the theory basically is to sell blocks of time as opposed to selling jobs. And I'm trying to really focus on making it so these purchasing crew and kind of procurement crew have an easier time and less stress trying to shop around and get quotes and all that. So I'm selling blocks of 40-hour increments, and it's so far so good. It's a little different. I think it takes a little bit for the initial people to kind of get used to it. And so got some new machines in. Been working on some of the miscellaneous projects and stuff like that. Been working on some wild new things that we could talk about with some of the questions and stuff. I was surprised at how many questions came in. I was not expecting that.
I think that a lot of people are still angry at me for not keeping you on the line for 6 hours last time. So they had a lot of questions to fill.
That's good. It's good. I like
that. Speaking of one of the questions though, and this will kind of dive back to the last episode. The last episode, you were going to work for a nuclear power company and talking about big graphite parts, and Obsidian Tools asked what happened with those. Did you end up using a Husk? Because you were talking about buying a UMC 750 or 1000, I think, and kitting it out. So what's the resolution of that story?
Yes, I did 3 years for the company. Basically, I just wrapped up my deal with them, and I did a whole master plan to basically, machine these basically extremely expensive, extremely high grade nuclear radiation shielding graphite blocks. And it's the one thing that happened was so we got the UMC 1000 in, and we got the VF6, and I did everything, and I got this sweet diamond tooling, which is that was my first kind of dive into diamond tooling for graphite. I've done diamond tooling stuff for lathe stuff, but this was the first time looking at it for milling, and I learned so much. The crew out at Decanter Tooling, they're out in Ohio. Decanter, Ohio, I think is where they're at. But they build this epic tooling, and so basically we built this whole plan. And then what happened was there was actually a redesign because they were able to make a little bit bigger blocks than what we had originally planned, which was actually a better thing. When you grow graphite like that, it's a really interesting process with the super high grade stuff. I don't know if you know much about it, but just, in a nutshell, they basically they'll make the graphite blocks, and with these super high grade, they basically cast it, and then they have to bring it down 1 degree every 6 hours. So you figure when you're coming down from 1,000 plus degrees, that could take days and weeks and months to get, depending on the size of things, it can take sometimes months to make each block. And so you have thousands of dollars per block. It's so crazy to get something that's basically 36 by 24 by 24 and it's worth like $10,000+ and you haven't even started cutting it yet.
Oh,
It's like super intimidating. And it's like, if you scrap this one part, basically like, the supply is already hard in the world, like not even COVID related. Like it's like already a nightmare to get a block. So you can't scrap it. So they were able to actually grow a bigger block or cast a bigger block than we were expecting. So we did a redesign. Well, that redesign like came like in this weird interim, like kind of shut down. We ordered machines, like things were getting moved in. I started doing the master layout and master plan for all the like production stuff. And then the block showed up. And when the UMC 1000 table would rotate, it was like an inch on the diagonal too wide. I was
oh
like,
no.
oh man, this is a total disaster. And so, oh, man, it was like I was kind of embarrassed a little bit, but that was like it fit when I did all the programming, everything fit, everything was good. Like, and then when these blocks showed up, they were too big and they're so big, you can't like they're like, you don't want to waste any of it. So the idea with it is also you got to like trim it, get it right to every like last little millimeter to the edges of these blocks. And so basically like at that point, I realized we had to like totally transition our whole plan. So what we did was we're building this earthquake simulator, which is kind of crazy. It basically is a miniature reactor that is made of basically metal and plastic. And it goes on these extremely massive vibration tables that mimic all, the movements of an earthquake. And the University of New York at Buffalo, they're actually testing it already. But since we need to build that, it was like, well, these are scaled down versions of it. So what we did was we actually just transitioned the UMC 1000 and the VF6 into like heavy plastic cutting. Because the one interesting thing is you have to get like a matching density for weight and size and everything to mimic kind of a scaled down version. And so we found a plastic that was actually pretty close to what the graphite would, kind of be in a scaled version. And so we transitioned all this equipment that we had gotten for that into building that. And it was amazing because it was already there. We were going to job out a lot of it. And then in that kind of interim process of when the graphite was showing up, we got one of those Aries big gantry routers. They had the CMS 5-axis, and it actually turned out to be the exact right thing. And we had already built the dust collection system, and so it all worked out in the end. But man, it's like I've worked on a lot of these big projects for these, like working for Elon and working for Larry Page, the Google CEO, and all these projects, and like the budget is there to like do the project right, but like, man, it's embarrassing when you like order the wrong stuff and it's like hundreds of thousands of dollars, and like, and it happens like, when you're moving fast and stuff like this, like this is the pros and cons of moving really fast. Like, and so luckily we were able to kind of just shift it, and we ended up actually basically paying for those machines just by doing that earthquake simulator from the bids that we got from other shops to do that work. So in the end, it was a break even, but man, it was like fine line of me looking like just a total dumbass.
Oh man. So the stock, like you're talking about rotating the seat, it would like hit the casting.
Yeah, exactly. Like, the casting on one side is basically like fully, kind of Frenched in to the main bearing, and then like closest to the door, there's basically the bearing support. And so, one side's a little bit closer than the other. And so, what happened was basically the one side it would hit. And I was
Oh
like, well, we could
no.
figure out how to like how we could figure out how to do this, and like, and then I was like, oh, we'll trim it down. I was like on every mission. I was like up late at night, like working, and I was like, oh, so embarrassed. But like, luckily, I didn't go. The original plan was like, to have a heavy loading FANUC arm that could transfer between the VF6 to the UMC. And
Mhm.
so originally it was like going to be the super automated system that could run 24 hours a day. And, when Makino actually will offer, it's pretty neat. Makino will offer any machine they basically already make for graphite. And so the one downside though is they basically build the machine in Japan and then they ship the machine to Ohio. They take the machine fully apart and then they reapply this kind of like custom graphite package, which is like seals. They change the linear rails to a oil injected system instead of grease, and they like basically cover everything and build extra sealing, and then they seal up the whole cavity. And so one of the original plans was to just buy like a massive 5-axis. It's the A81X, which is like the big 5-axis portal head horizontal, and to actually do these blocks on that. But the one downside with that is like also you have this massive, expensive graphite block, being held like off these fixture points, and like you're just paranoid. Like, and so, all in all, it just came down to like it was funny because this was my first idea was just to use the router and just go that way. And then I like went too far down the wormhole, like trying to save money and trying to like be able to use these machines for everything. And it's like, that should be the moral story. It's like your first guess is usually your right guess, And so, yeah, well,
Oh man.
it all worked out, but man, it can be really embarrassing. Like, moving fast is super fun and exciting, but in certain roles, it's extremely stressful when things go haywire. So,
Yeah, no joke. Well, and if I remember right, that Makino, it was like one UMC's worth of money extra to like get a graphite prep, wasn't it?
Yeah, exactly. I was like 250,000 just to add the graphite package to an already $1 million+ horizontal. So it was like, yeah, and it was, and they were pretty confident they had never done one before. And so it's also like there's like this also like, well, they've never done one yet, but they've like done something similar, but never that big, because like the it's so rare to find like anyone that's doing graphite at that scale, because that scale is just, it's like, I mean, you're like millions and millions and millions of dollars and 2 years out just on graphite. And that's crazy, because you need to know your project so far out in advance, and you're in your planning and stuff. And that's the one downside that like a lot of people aren't talking about yet in the nuclear industry, is the worldwide demand on certain industries that like, just to build it's so easy to be on YouTube and be like, we're going to build like, 80 of these reactors and build 80 of these and 80 of these, and it's like, when you actually break down the supply chain, you realize that there's not even enough supply for like, some of these, like even half those numbers. And so you really got to reinvent that whole system to basically handle that volume. And it's not a quick process. So just making those blocks takes 2 years. So it's, you could set up a factory, but you'd have to wait another 2 years to get blocks out of it.
Yeah, I think that a lot of those supply chain issues are starting to pop up in the world. I had no idea that graphite was that, I guess not rare, but hard to come by. Like I would always have assumed that the limiting factor was radioactive material for the reactors.
Yeah, it's, that's another major stepping point, is like, everything needs to be basically like an ITAR like level, as well as export control. So like, just doing machine work and finding vendors and, going through the whole procurement process turns into a lot of steps. And the supply chain is going to be a huge major factor. And a lot of it is like, the people now have also a lot of money. Like, this is not nuclear related, but just a lot of these industries have a lot of money. And so like one example is, I was working on this project for basically doing LG to jet fuel. And, it's like this one piece of stainless pipe, and there's like, COVID took a huge hit on the stainless steel tube industry, and it shut down one mill. And then the other mill basically found it was perfect time to go on strike. Right. And so like,
Right.
they basically held all this tube rants, and it was crazy because like, the small shops, they can't afford to be competitive, but these big companies, they just got competitive, and they were just like, well, and I called up the one tube mill, and they were basically having a bidding war over the last piece of polished eighth inch or 8-inch, like, 316 tube. And I was just like, what's the deal? Like, and they were basically like, well, normally it's the $5,000 tube, and now with like the demand, it's 10,000. And I'm just like,
Oh my goodness.
it's a piece of like 109 thou wall thick polished stainless tube. Like there should be no reason you're paying $10,000 for a piece of like tube that's 12 feet long. Like, it's $1,000 a foot. So it's
That's
insane.
crazy.
And
Yeah. Well,
like
I
that,
was watching a video that like even rubber and stuff like that is going to take a big hit these next couple of years because it takes like, I think it was 7 years for a maturity on a rubber plant. And like
yep.
with all of COVID, like nobody was buying rubber. And so like all the producers kind of tapered off. And now we're 7 years out from the next big crop of it.
Yeah, and it's an interesting thing because there's like, that I think it's like it's a blessing and a curse, right? And maybe allows people to really rethink the industry and how they do things. So I think, like one of the like problems that we've had like since basically the 80s is like, back in the day, everything was like made on demand, right? It was like, but you bought a Schwinn bicycle, you ordered it at the bike shop, and then you waited like 2 to 3, 4 weeks to get it, and then that was it, right? And so this like whole Amazon effect has happened in the whole industry. And now people have come to expect everything like now, but it's also like changed the whole world of manufacturing. You're seeing a lot of like things becoming so fast and so automated. I mean, just looking at what like Autodesk is doing, and making tool library systems and, like being able to intuitively look at parts and figure out all the features of it, like that kind of stuff is going to end up, becoming more common. And I think just like the systems and the machines are going to get faster and hopefully what that does is that allows people to be faster on demand. And hopefully that like also reduces some of the needs because like a lot of the supply chain is damaged because of we overproduce things based on forecasts that are like done years in advance, right? So they're
Yeah.
like predicting a shortage of rubber tires and it's like, well, like what's saying that? Well, they're saying like, we'll use 2018's data and we'll say like, we need to make a lot of tires for this next year, And it's like, is that the right data? Or is the better way to do it is to like, produce a small amount and have them be able to be produced really fast. Right. And so as the whole manufacturing industry changes, there's a lot of companies out here in the kind of West Coast kind of tech world that are more focusing on how to do things really fast on the computing and algorithm side of it, as opposed to like just mass produce things and then put them on a shelf. Because I think the sustainability of the industry, resources, and the economy and everything else, like it just it can't support the like just stuff sitting on shelves.
Yeah,
So
I completely agree. And that I've seen now that I've worked in aerospace long enough and talked to like our purchasers and stuff, you see that like it's crazy how many companies are misusing MRP systems and
yep.
like reading data that doesn't really say what they think it says. And like they'll keep ordering parts and ordering parts because they're like, oh, we're a line down. But then they don't realize like, oh, my MRP system might not be realizing I'm ordering these parts and that they have a lead time and it's just telling me to keep ordering them until they show up. And then it's like I'm going to have 6 months or, a year's worth of inventory when I really only wanted one order's worth.
That's the blessing and the curse, right? Of an automated system like that. And I think a lot of that also is like we're still in that like I feel like a lot of those systems also are kind of like Microsoft Word, right? They're not special. They're like they work. And so like the problem is it's not the same as handwriting or like any of these other things. It's like it's faster in certain ways, but it's also like more disconnected in other ways. And, so I see that happen a lot. And also you'll overstock on things and yeah, this things get messy. And a lot of it is because the transparency isn't there also between the buyers and like the people that actually need the stuff. And so, that's the problem with these companies also getting like so big and disconnected from certain systems.
Yeah. Yeah. It's a strange world. I think that like most of the advancement on the software side is going to be filtering the garbage. It seems like in the next couple of years, like we've got like the automated side of like, oh, we'll place this PO if you need it because you're out because your system says so. But like there's all of that like noise that's introduced by having a human interact with an automated system that we just haven't gotten really good
Yeah,
at like filtering out yet. Like, oh, maybe we don't need to order like 40,000 of these parts because we only go through like 10 a week or something like that.
totally. And it's interesting too, because like, the whole, like, when Schwinn produced bikes, one at a time for customer orders, they would like produce like, a few extra for showrooms and stuff. And those are, people that want to buy that in an instant, but you get what you get, right? And now we overproduce things. And the interesting thing is like sales and closeouts and stuff didn't come around till like the late 70s, early 80s. And that really was all driven by the amount of imports happening on things and the overstocking of things from mass production. It's like we can make things really fast and cheap, but it's also like, then, is fast and cheap the right way when it sits on a shelf for a year and then you have to sell it at cost at the end of the year? And so it's not good for the environment. It's not good for, there's a lot of people out there that make money off that section of it, but it's like, really, it's not the right way to go. And manufacturing will, as it keeps evolving, will pick up some of that. And I hope that things become more on demand. There will always be a need for mass production stuff, but I think hopefully certain things are not just less energy intensive and resource intensive to move fast.
Yeah. Oh, yeah. I totally agree. So that takes us where we were last time. There's a few questions about updates on other projects you had mentioned too.
Right.
Prometheus Lights had talked about the garnet mine and the airplane. Jason
Yeah.
wanted to know.
Yeah, and hi Jay. We need to catch up one of these days. But either way, the garnet mine is sitting at its current status. The goal was, in case the price of garnet for water jet spiked, I would own a mine. I bought it as a joke, and then the price almost went up, and I was like, I had dollar signs in my eyes. But yeah, it's a fallback plan. And for anyone that didn't know, that I accidentally bought 22 acres, which happened to be an abandoned silver mine in south of Helena, Montana. It's basically in like the Ruby Range, where basically Ruby garnet comes from. And the interesting thing about it, when they dug for silver back in the early 1900s, late 1800s, they actually built all this piles of tailings, and they were like super bummed out about it because it's like this really hard kind of ruby like granite it's really hard to dig in, but that's where the silver is. And so they made a perfect pile already of garnet for me. So I'm just waiting for the price to raise up. And then the airplane, it kind of goes hand in hand with the mine, right? Because like when you got 22 acres in the middle of nowhere, you need to build a landing strip there. So the plan kind of goes hand in hand to finish the plane. So Crystal bought the wings recently. So we decided to go with this. There's a small little machine shop down in Florida that produces wings, and they basically came up with their own design, and they hydroform, stamp, and extrude and mill everything in-house. And it's super cool. So basically they took like a 1960s, 50s, 60s, 70s, 80s, 90s Super Cub wing that already is designed. They stretched it out, and they also made it a little taller so you can do those extreme super stall landings and takeoffs that everyone gets all wild and crazy about. So they basically, by putting a bigger wing on it, you could bolt this wing onto your stock Super Cub. And since we're building kind of a mutt that's based around a Super Cub, it's pretty neat because we can basically bolt these wings on. So a little bit expensive money, but I also, being a machinist is kind of, I like supporting machinists that are doing cool stuff, and these guys built some cool wings, so I didn't have a problem spending some money. Actually, I didn't spend the money; Kristen spent it. So
Well, that's really cool. That's awesome to hear that there's still companies out there doing that, because you'd expect, like you said, with the Amazon effect, that all that stuff would just dry up and they'd take you to go buy a new plane or something.
Yeah, you definitely wait for that stuff, because there's not a lot of demand for it. So it's like, the wings are expensive, but you build them yourself. They do it for liability. they're like, you can do everything yourself. That way, we're just a machine shop selling you aluminum. So, right. Which I understand, and I don't have a problem with that, because there's enough of them out there to feel good about it. And then the other cool thing was I built all the landing gear for it. And we're about 80% done on like the build of it. And then it's basically just the fuselage is ready for paint. Basically, I just need to sand some of it down or sandblast it and it's ready to paint. But I built all the landing gear for it. And then I was just like, what the hell? Like, come on. This is 2021. Like I can't just build like 1950s landing gear. I gotta like do something way cooler than this. Like there's so much technology improvement since then. So I actually found a little machine shop that's out in the middle of the Central Valley in California that designs and builds off-road race truck shocks. And they also do shifter cart shocks. And they started doing airplane shocks because there's like this kind of demand for these like long travel shocks for backcountry flying. And so basically I like did all the layout for them. And this guy like machined and built these shocks for me. And they're super badass. They're 48-inch eye to eye, so they're massive.
Gee.
And yeah, they actually have like a redundancy system because when you fly airplanes, it's like the one downside with land gear, if there's something wrong, you usually don't know until you land.
Right.
Like,
Right.
so if the gas in that shock freezes and that seal freezes and that gas leaks out, you could totally get, to the point where you basically like come down to land and the thing tilts at like a 30-degree angle and loop it out or something. So you always want a redundancy of some sort. And so this guy builds basically an air shock and then he puts a spring inside of it as a kind of a helper. And so super cool. So then I had to restart the whole project and build all new landing gear. And then I had to beef up the fuselage, but man, it's going to be sick. I'm so stoked. It's an Alaskan Cadillac, that's for sure.
That's awesome. So between that and the wings, you'll be able to stall out land on like,
It's gonna be
the
awesome.
roughest terrain out there.
Yeah, I can't wait. Big tires. What do they call it? They say long props and big rocks or something like that. Like it's like that's the Alaskan dream right there.
That's awesome. So speaking of other projects, Molly No asked about the espresso machine.
I mean, that's a classic. That's a career project. That's my journal of my career, basically. But I've told a lot of people that, but like the idea with it is like, as I progress in my industry, I needed some way to document what I've learned. And so every time I basically learn something new, like when I learned metal spinning, I built the boilers. And when I learned, how to do certain tool paths and stuff. And so right now, what I'm working on, actually, I just did a project where I designed and built a screw for moving things, which happened to be like similar to a coffee bean, not a coffee bean, but made similar to that. And so then I was like, I learned how to do the tool path because it's a progressive flighting and I was really stoked about it. And so I was like, this I'm going to make into an auger to basically haul coffee beans around the machine. And so
Oh, that's awesome.
and then the other thing that I started some of the fusion model on it, but I want to do basically like kind of like a Arberg, like electric servo driven injection molder, how it's got those linkages. So what I want to do is I want to actually grind the bean and then I want to like kind of place it into a funnel that funnels it into kind of an injection mold cavity. And so instead of putting it into a portafilter, you basically put it in an injection mold cavity and then clamp it to a certain designated pressure based on the servo drive, and then inject the water through it and pipe it out that way. And so the idea is like make this system. And so I started designing a bunch of it, and I was just like, I looked at it and I was like, oh man, this thing is gonna be a total nightmare to clean. So I think I gotta go back to the drawing board because just cleaning a portafilter is a mess. Like it's
Right.
weird. Like coffee's like working with dirt. It's like it's amazingly like when it starts sticking and gumming up on stuff and the oil, and so yeah.
Yeah. Oh yeah. Yeah. It's like dirt plus oil. Like it's not an easy thing to clean regardless. So
But I think the key there is like, I plan to make my first cup of coffee when I turn about 90 years old, and it'll probably be the cup of coffee that kills me, but man, it'll be a hell of a ride. And, the goal is like every time that I like learn something that like really excites me or, something that I kind of take what I've learned and transfer it to that and make another part for the machine. So yeah, I wouldn't expect to see that for at least another 30, 40 years.
All right. Oh, well, we'll have to check back in. We'll have you get back on in a couple of years. And
Yeah, perfect. Episode 796. We're
yeah,
talking about the machine.
exactly. Let's see. Paul Alfaro asked, any cool new bike things you've been working on?
So just finished up one of the projects. It's on my Instagram. It's a little electric Honda. I built a bunch of the parts for it with kind of a bunch of friends. They really did all the work. I just kind of I would just look at it and be like, come on, guys, you can do better than that. And then I was like, great. Now I feel like I'm held accountable because like I'm the only one that has the machines that can do better job.
Yep.
So then I felt obligated to cut parts and make a bunch of stuff. And you know what? It turned out super sick. And it's like, if you haven't taken a look at it yet, you can go out of my Instagram and look at it. And then there's a link to the Bike XF article that just came out. And it was crazy. It got like 2 or something million hits just on the website. And they were really stoked. Like, is that basically took a little Honda that would normally have like a little 250cc scooter, like CB 250 or 360, sorry, 350, 360. And we basically put a battery in it.
Yeah. So you put this awesome battery in a Honda, beater Honda pretty much, and it is gorgeous. Like,
I mean, I was just helping out. Building electric bikes is like one of my building anything electric. I've been like an electric nut since like about 1997, 98. And man, like I've been really fortunate to work on some of the coolest projects too. Like a good example is the Alta Redshift dirt bikes, the electric dirt bikes that got really famous. They were starting to like battle in the Red Bull Eat Straight Rhythm. If you're a dirt bike person, you've probably seen one, and they're indistinguishable of being like a normal dirt bike, but man, they are super fast. They have good range. They were so far ahead of their time, like the machining and the engineering and stuff. And so I was lucky to work on the first like concept bikes and help with the design team on a lot of the projects. And that was really cool. Another really cool project I've been involved in is the boosted boards, the electric skateboards.
oh, nice.
And so like I have board number 6 hanging on my wall. That's how early I was part of it. And a bunch of these guys like Sanjay and Mark and everyone, they and George, they all approached me and were like, we want to like work with you on this. And at the time I was probably like, I don't know, it was like 23 or something like that. And I was like, yeah, I could do everything. This would be no big deal, right? And like at that point, like I've been building concept bikes and stuff for years. And so it was like no big deal, but I really wasn't ready for the like response that the public had to this thing. Like, so like, I made like 100 parts and I was like, oh, this is awesome. Right. And then when the order came in from like thousands of parts, like it was the first time like I had ever, like on my own gotten orders for thousands, and then it turned into 10,000s of parts. And I was like,
Yeah.
And I was like so confident that like I could just hang in there. And I was like,
oh
yeah,
man,
that is trial by fire. Like I feel like the whole time, like I had fallen into the pit, but I was like hanging onto the bridge, and I was like slowly like walking my hands across the bridge, dangling underneath it. Like I was like almost falling in the pit at every time. And it's amazing because like I think like growing up, I worked in machine shops, and I seen how easy it was to like, this company I worked for, we did all the Caterpillar and John Deere brake master cylinders, calipers, gas pedals, everything. We do like orders of like 10,000, and it just looks so seamless and easy, right?
right.
Like when you're doing this on your own, this is not easy.
Well, to scale too, from like,
Yeah.
some prototypes to tens of thousands it's no joke.
And I thought I was gonna like, I was like pretty good at machining and I was pretty good at stuff, but like I really thought I was going to become like a master of the progressive die stamping, as if it was something I was just going to learn on my own by trial. And anyone that like listens to this is probably just like, that's impossible. You can't just like just walk into injection molding or walk into progressive die stamping and just say like, I'll figure this out, right? Like it was like it's not a quick thing to figure out. The like mastery of that craft of those two things, like, and it's so easy when you look at the stuff, and then just to like when you actually try to do it, it like gives you a whole new appreciation to everything you see in your life. Like it doesn't matter if it's a spring on a pen, or if it's like some solo paper or solo plastic cup, it's like it gives you a whole new appreciation to the mastery of all these people involved in everything. And it's just like, man, like if only the world knew how much work and skills and understanding it takes to get to these, like, to the ease of what we live with today, it would, I think, also make people more appreciative of the things they have and how much they take things for granted.
Oh yeah. Yeah. I mean, even just being a machinist, like, and not going through additional processes like that, I feel like a lot of the listeners will understand what you're saying. You start seeing, you're like, oh, everything is made from like a mold that a machinist made, or, this
Yep.
or that. And like, it's really cool to have that kind of perspective on life.
It's also crazy too because like, you sometimes see these things that like you're just like, oh, it's like a plastic toy, that's like comes in everything, or like, that kind of stuff. And you realize that like, these toys take like a 10-part mold, right? And it's like you're like, holy, there's like so much work in just this toy that basically gets thrown in every Happy Meal. Like, and you like just lose perspective, I think, because we take all that stuff for granted so much now.
Yeah. Yeah. I totally agree. So jumping back real quick, you helped out or machine parts for Alta? Cause like that was my dream motorcycle. Like if had they not, cause they got bought out, didn't they, by Harley or something?
Yeah, it kind of was like it was a disaster. The partnership turned into basically a disaster. And some of the people left, and like the company basically filed for bankruptcy, mostly because they put too many eggs in one basket on a partnership deal. And like, I don't want to go into the details because I probably am wrong in saying some of the stuff, when it comes to business stuff, it's something I'm horrible at. I basically run a nonprofit because I've yet to make a profit. But basically, like that bike, I stay far away from that side of it. I don't get tied into any of the investment or any of the money side. And it allows me to like really just enjoy the project. So
Totally.
a lot of times you can be totally jaded on a project because it's like, it's out of funding or it's out of this. It's like, if it's almost out of funding and you believe in it, you should be working harder than you've ever worked. Right. And so
Right.
like,
Yeah.
but Alta was a really interesting one. There was, it was random. I was just walking through San Francisco one day and I seen this like super epic building, and it had this like amazing machine shop in it. And I peeked in the window and I started talking to people, and I was like, what do you guys do here? And they're like, oh, we are like a design firm and we make like all kinds of random stuff. And then I like met the owners, and then one of the owners ended up being one of the founders of Alta, and super epic designer, like probably one of the best designers I've met in the United States. His name's Jeff Sands. And basically, yeah, he was like him and another guy, Derek. Derek now is one of the main guys for a Damon Motorcycles, the new electric street bike. And so he's like basically heading up manufacturing for them. So, not all is lost there, but those two guys and a few other guys basically like they were like, hey, like, you do welding and you do sheet metal and you do machining, and Derek runs an epic machine shop already. So he could do a lot of the stuff I could do. But what I was capable of doing is kind of like right at the advent of big size 3D printing. So it was kind of still too expensive. And also it was like, I don't know, it was just hard. You'd have to glue all these pieces together. And so what they decided to do is build the first like concept bikes all with aluminum bodies, which were super badass. And so I built the aluminum body, so hammer all the panels and do all the work that way.
Oh my goodness. Yeah.
That's what I used to do. So it's like I used to build concept bikes for Ducati, so it was like not a big deal to like build that bike. I was like, this is the easiest bike I've built. It's a dirt bike. It has like no panels on it. And there's like no panels that meet each other. So like when you're eighth of an inch off, like no one's. But if you look at the number one concept bike, I'll let your viewers into a secret. But if you look at the first one with aluminum bodywork, if you look at the skid plate, the blue bike that you'll find if you search up Redshift, or Redshift is what it was called before Alta. You'll look at it, some of the panels don't fit, so there's like bolts missing.
Oh
Hey,
no.
I was freestyling, I was in a rush, so like
Yeah.
cut me a
Yeah.
break. Most people would never say they made an error, but I definitely came up short by about a quarter inch.
Oh no. Yeah. Their supermoto. I was like hard set. I was like, as soon as, I saw my street bike, I'm going to buy one of those and that'll be my daily driver. Cause like was one of the first electric bikes that I was like, that's good looking too. Like
Yep,
it's not like
totally.
the zeros are like okay looking and they're
They
starting
still
to get a
have
lot better, but like the
yeah.
Redshift was just such clean lines and so done so well.
Yeah, and that frame was actually what the frame on that bike was a masterpiece. Like you don't even you can't even comprehend how amazing that frame is because it's all hidden, right? And so
Right.
like a good example is like so it's fully sand casted front section. That front section it can only really be made by one company and they like basically 3D printed all these cavities and then did a sand casting and then they like inject nitrogen into the sand, harden the sand with the 3D print binder, and they built full channels, cooling channels all the way through that front end section. So the radiator actually is non-existent. It just flows through the front end of the frame. And so
Wow.
like the idea was like you have this dirt bike and like how do you make like Tesla made cars better by basically redesigning the whole car. So how do you do that same thing with dirt bikes? So you get rid of all the things that always break, right? Like just get rid of the
Radiators.
radiators.
Yeah. Right off the
Yeah,
bat.
yeah. Get rid of like anything that's like out there ready to break. And so this frame was amazing. So they basically sandcast this frame and then they would have like they'd rip apart the cope and the drag on the sand casting box and you'd have just this like block of sand. What they had is it was super fucking epic. And I don't know like it's who knows if it's proprietary, but either way, like it's they have FANUC arms with water jet nozzles. And what they did was they built a computer model of how the frame would cool as it came out of the sand mold. And the water jet on these FANUC arms was programmed to basically shoot through the sand and hit the aluminum and cool the aluminum in a certain way during like the cool down process while they break the sand mold so that they could basically relieve the stress and do a stress relief at the same time as breaking the sand apart, as opposed to sending it through multiple stages. It was
Wow.
badass. Like I'd never seen anything like it before. So, I mean, I had done sand casting stuff for years, doing all the stuff for Caterpillar. So it's kind of like, it was crazy to see this. And I was like, what the fuck? This is awesome. Like, what the, like, it's just, normally you just see like the sand just get broken apart and get put through the mulling machine to turn back into sand to use for the next mold. And, working at Edelbrock, it was the first time I had seen a fully automated system, like start to finish without anyone really being involved in it. But this was like next level of like, taking computer models and then testing it and then, building this like secondary process into it. It was super badass. Like everything about that bike was so far ahead of its time. And it sucks that like it turns into a management problem that actually ruins the product. The people that were passionate were making that company so good. And then you add in a bunch of people that just want to make money and it just ran that whole plane right into the side of the hill.
Right. Well, and
So
it sucks too, because like that's the second electric bike startup out of that area that like
yeah,
got me super excited, because Mission Motors was the other one that I was like
yeah.
super hot and bothered about.
Oh, that was
And
such a cool bike.
yeah, well, and I didn't even realize until after recording with Jason that he was a part of that, or help,
Oh yeah.
somehow part of that project. I told him over DM recently, I was like, dude, you're gonna have to come back on, and I'm gonna have to pick your brain about that, because that was the first electric bike where I was like, oh, I want an electric bike now.
I
Like,
think there was like 3 or 4 guys that were really involved in it in the early days, and then one of the guys that was the main guy went to Google to work on self-driving cars after Mission went under, and then one of the other main machinists other than Jason, I think, moved to like New Mexico. He's like in New Mexico running a machine shop down there. So, but yeah, it's like that bike was well far above it and ahead of its time. And it, the problem is it was just like it's the same thing with Tesla. Like all these projects came at that same time in like 2010 to like 2000, maybe like 14, 15. And like everything was like the stars had aligned for the project but the customer base was still like in the kind of confused state. Like right now, if you came out with that bike, it'd be a slam dunk, like, but the problem is like, Damon Motorcycles is building traction like crazy and like everyone's getting amped up about it. I also, worked with the crew at Lightning Motorcycles, Richard, and helped Richard kind of tool up for building his sport bikes. And they have the Pikes Peak record, the overall record, and they did it on that electric sport bike. And but yeah, like, it's crazy to see like how ahead of the time they were, but then the market wasn't there yet. And so now the market's there and people are really excited, but now it's like people are like, it's the bikes are super expensive because basically the battery is like the holding factor on price. So
Wow.
yeah,
That's nuts.
it's cool to see all the like. I really am stoked about the way things are going, like on the kind of automotive and the electric vehicle. The next one that's coming up that's going to be really cool to see in the industry is hybrid and full electric planes. And that's one thing, my girlfriend Crystal worked on for like many, many years doing electric aviation. And so it's cool to see it like build traction now. You're seeing Mercedes-Benz just bought Yasa, which is the electric motor producer they basically have a collaboration with Rolls-Royce to build a hybrid electric airplane project. I have
Wow.
another. Yeah. And like, so it's like a turbine that runs a generator, kind of like the way a train operates. So you could do electric motors. And, for things like a V22, like Osprey, it's a pretty big deal because, the Osprey is an interesting, thing because you basically have the turbine inside and then you have drive shafts, running all over on this thing. And it's like, you've like these super long drive shafts and you have like all this extra weight, all these weird places. So now what happens when you can put the turbine in the center, like in the fuselage section, and then you can move the like electric motors anywhere you want in any direction at any point, and you can speed them up and slow them down. When you sit on the runway at taxi, you can just run off battery power and leave the turbine shut off. You reduce turbine hours, you reduce your carbon footprint. You just like, you build a more streamlined system. You can also regen, and there's just like you have no noise when you're sitting on a runway. And so like everything about this is the way it's got to go, and it's going to go. And so it'll be cool to see like in the next few years, like all the machinists that are going to be starting to work on a lot of this. And I have a friend, Ian, who's working on a really crazy project he's kind of getting started on, and it's a hybrid electric, and it's super, super cool to see the efficiency ratings of things. And so it's going to be neat to see like in the next few years, the way things go.
Yeah. Oh yeah, totally. I'd never even thought about something like Osprey like that. And not only efficiencies of like keeping the turbine off, but like, I mean, the whole thing was supposed to be a, special ops plane in the first
Stealth.
place.
Yeah.
So like if
Yeah.
you could run them straight off of electricity and turn off the turbine, that'd be amazing.
Totally. Yeah. All you would have would be blade noises, and actually, the blade noises are getting better and better. Like the company that makes the V22 blades, the processes they make is actually pretty amazing. And I don't know if you know much about like compression molding composites, but the way they make those blades, like it's transforming the way blades are made now. And it's like, basically it's like injection molding meets carbon fiber layup. Right. And so you basically lay carbon fiber into a mold and you close a cavity with extreme pressure, like an injection mold. And instead of injecting plastic, you're injecting basically the resin, and you're able to kind of, you can open that mold up in like minutes and pull out a blade, as opposed to like a wet layup or a vacuum bagged or anything. And so you have this whole new process where you can make things super fast, but you can also do geometry that you couldn't do before because of the compression ratio. Like you can basically work into corners and do things you couldn't do where like, normally you have soft corners on composites because you can only push it in so hard into a corner. And so you can do things you could never do before. And you can do shapes, like you could do a golf ball, like a composite golf ball, like the
What?
bubbly, like, yeah, like you can do things that you couldn't do. And so, yeah, it's that whole industry also is going to transform a lot of the tooling world. I think you'll see a lot of injection molders in the next maybe 5 years transferring to compression molded carbon kind of companies. So
Wow. I had no
yeah.
idea. That's such a cool technology.
Yeah, pretty wild. I've been the first companies to really do that compression molding that like a lot of people can use as an example is the BMW built that i3, which is a little electric car. And if you ever see one of those, like definitely ask to open the doors up and look at the chassis on it. But what they did was they actually compression mold the whole entire chassis out of composite, and then they water jet all the holes and door holes and everything out of it. And then they shred that and they make other components using the compression molded out of the scrap. And it's the life cycle of it. It's super crazy. It's not very good for like, there's some companies out there that are recycling composites now, but it's a slow industry because the price of composites is still super cheap, just like plastic. But yeah, basically it's the BMW i3 is the first kind of heavily produced compression molded composite thing in volume. And so it's pretty amazing. They can make a car like every few minutes. Just, what would have taken probably days to lay up can now be done in minutes.
That's crazy. You have an i3, don't you? Or you had one?
I do. I love it. It's awesome.
So
It's the little jelly bean.
right. So speaking of electric vehicles, you've got that. Do you still have the Rangers?
We do. We sold one of the Rangers to the guys that are starting up the company Altus, the electric guys down in, I think they're in Phoenix. And we sold one of the Rangers to them for their lunch run. They're coming out with like a new like kind of F-150 to F-350 sized truck. They're going to do a dually and stuff, but they needed a cool vintage truck to be in cool with the crowd. So they bought one of our converted lithium ion trucks. And then Crystal just finished up another project, and basically one of the defunct electric vehicle companies around here in the Bay Area was like trying to scrap out a bunch of stuff. And just so happened there'd be in that scrap pile a bunch of LG batteries, which are
No
like
way.
unused, like easily like $25,000+ battery packs. And the project went belly up, right? And so they're just like, we need to get rid of all these batteries. And so, heck, like perfect. So she's got a little Ranger, and that one can go, it's like 250 miles is what it can go on that little Ranger. And so
That's amazing.
it's always funny because like when you pull up in like a 1999 Ranger to the EV chargers, like everyone gets so mad at you because they're like, this is for electric vehicles only.
And then you plug it in and they're like,
Yeah.
oh, okay.
Like, because like, everyone just assumes that like electric vehicles are like 2015 and newer.
Right.
So
yeah. They don't see a Tesla badge and they're like, nope, not an electric vehicle.
Yeah. And that truck was super far ahead of its time as well. So it's cool. It's like a piece of history. So there's only like 250 of them. And of that, they're mostly in Norway now. Actually, most of them got shipped there because there isn't really been an electric truck until this F-150 comes out. There isn't a truck out there that you can use. So this was really the only option. And there was a guy in Norway, and it just so happened to be perfect luck that my girlfriend, she works on wind turbines, was in Norway working on wind turbines, doing crane work and stuff. And the guy that converts all these Rangers happened to be right down the road. So like for basically a whole year she was there, she learned as much as she could learn about these trucks from this guy. It's like so random that the one place she ends up having to go to work that's like super remote happens to be the one spot with the person she needs to talk to.
Yeah, that's crazy.
Yep.
So what, like, it's the rough cost of like one of those conversions?
So that truck is not a conversion. It was actually built by Ford. And so what Ford did in the late 90s is they knew that they weren't at the level yet to like fully design that system. So what they did is they actually subcontracted out Siemens to do the whole drivetrain and inverter. And so that truck is actually like not far off from like what, is like a current EV. It runs a full AC system. It runs everything like really high end. The only catch with it was like, that was super high end, and all the German stuff was, but then when it was put onto the Ford chassis, it's like, that's when things get a little goofy. It's like the Ford didn't want to invest the money into building something kind of ground up. So they just put it on frame rails. I think that whole idea has changed now that there's like a whole different world there. But it was funny because that truck was originally built on the Ford chassis because the idea was we could build it on the Ford chassis. We could put the post office box trucks on it because those are built on Ranger chassis. And
Really?
and so like they really wanted to build these so that they could really just like build these chassis and then just take all these conventional post office trucks and then just put the bodies onto these rollers. And that was a total fail because basically in 1998, 97, 98, when they came out with this truck, the only option yet was lead acid batteries, right? So like imagine having a lead acid battery, that's like heavier than the truck weight, and it's this massive battery pack. And then like it being like a cold Minnesota morning, right? Like, and so you like combine all these variables and like it's awesome. There's multiple people I've met, and there's one guy on Instagram whose dad actually worked on the Ranger project in the 90s. And it was awesome hearing all of his stories about like his dad having to like tow it home with the F-150 all the time, right? But basically the lead acid batteries on a cold day would give you like anywhere from 5 to 10 miles of range. So it's like you can literally like barely make your mail route with 5 to 10 miles.
Yeah,
right?
you'd be better off with like a bicycle at that point.
Yeah. And so like, that was like the rough start with the, the electric vehicle program. And then, if you do a little bit of research about electric vehicles, you'll learn about the Chevron deal that basically they bought out the patent for the nickel metal hydride battery, allowed every other industry except for vehicles to use that battery technology. So like, that's why like cameras and camcorders and all this like handheld stuff evolved, but like electric vehicles didn't. And, when the need was there for a battery that could actually provide a 200 plus mile range, which was the nickel metal hydride battery, the patent wasn't allowed to be sold to Panasonic to basically be used for production of cars. And so that's why like, basically all the way into the 2000s, no one was basically running electric vehicles. And it's like, that's the irony of it. It's like the oil company ends up doing the most damage. And if you think if they can hold off for every day they can hold off, that's more oil sold. And so it's sad that that's the way the system works, but whatever. You don't learn about it usually until it's like done.
Yeah, exactly. So Paul's other question was about cutting time, which you had not even, I think you had kind of off air shared with us that something was coming out last time you were on. So talk to me about getting your first, or I don't know if it was your first patent, but getting a patent, starting a company, selling all these parts. How'd that all go?
Yeah, it's super cool. Like it's just a bunch of stuff I've been working on for a while, and I needed to like kind of evolve the business a little bit and get away a little bit from it being so kind of wild, loosey goosey with Monkey Like Shiny. As the name describes, it's kind of a goofy company, and I think I needed to be like a little bit more ISO AS9100 style, right? Like by going like a little bit more conventional name. And so, as I get into these more intense projects, like, back when I was Monkey Like Shiny, I would, get these jobs in from Boeing. I worked on parts for the Dreamliner seats, and it was like, it was just the idea that like Boeing sending a check to Monkey Like Shiny, like kind of like was weird, like I like felt like kind of a little bit embarrassed, but also kind of proud that like, but so it was like time to change the name. And so that transition happened, and it was funny. I was just standing at the machine one day and I looked at the screen and it said the amount of hours of cutting time. And I was like, like this has got to be taken. Right. So I like just did a quick like GoDaddy search, and cuttingtime.com was available. And I was like, this gotta be crazy. And I asked my tax guy, like, hey, he does business stuff as well. And I said, hey, can you do a search for this quick? And he searched it up and he's like, there's a salon in Florida named Cutting Time. That's the only other business in the whole United States. And so I was like, done, bought cuttingtime.com and kind of set it all up and kind of build a more professional oriented company. Monkey Like Shiny will always stay, but that will be like my personal brand of like goofiness and having fun on concept stuff. So yeah. And then, that it's kind of the same company, but a little bit different. And so cutting times, like one of the main things there was to kind of develop a bunch of tools and things to kind of make, working in the machine shop easier and more enjoyable. And so some of the stuff I came up with was basically like shooting fish in a barrel. Just watch a Haas machine and see all the problems it has, and like make improvements to it by selling products. And so one of the things I came up with was, sprayer nozzles to upgrade like the coolant jetting so that, you're not getting chip buildup. And it's crazy. Like, some people buy them and they're like, it works pretty good. Like, it's not exactly. And then some people buy them and they're like, it's like night and day difference. It's like made all the difference. Like, like Eric from Orange Vice, is his machines, he's running like heavy pallet production on some of the stuff. And on some of those machines, he gets just tons of chip buildup. There's also a few manufacturers of like lowers and stuff, and they were doing a lot of milling on the big machines, and they were getting piles, and they were spending every few hours on this company that they did lowers for, like for sale, I guess, but their main specialty was actually building airplane wing supports for like Gulfstream. And they were just heavy milling, and they said they would have to stop the machine like every 4 hours, push all the chips forward. And then like, they were even using the multiple augers. And so they said they bought this thing and they put the jet exactly where like they were just doing heavy, like pocket buildup. And they said, that's it. Like it literally, now they do a one sweep clean in it like every like 2 to 3 days, and they're able to do that. And so that was a major one, and it's cool. It's like, I don't know, it's done. It's figured out. I just ship them out like every day. I just ship a bunch of them out. There's so many VF machines out there. It's cool. I don't spend any time marketing or anything. I don't really have the time to do all that. And then,
well, having run a VF4, like it's so needed. You shouldn't spend time on a machine with like augers or a conveyor,
yeah,
sweeping out chips. So the fact that
exactly, it's not a Fadal from 1997,
right?
And then it's like the other worst part about it is the minute that you actually run like a nice German or Japanese built machine or a Korean built machine that actually has like legit, like figured out coolant stuff, you're just like, wait, the Haas is really this bad?
Right. Yeah. What's crazy about it is it's mostly just sheet metal design. Like all of the ones that I've had that have the best chip evacuation, like they don't need that much extra coolant to do it. Yep. It's just like, oh yeah, you angle it towards the chip pin and it all of a sudden drains. It's crazy.
Yeah, it's crazy. Like when you open up a Matsuura Hermole, like, and you look at it, and it like, you're like, you're not running this that often, right? And it's like, what are you talking about? This thing runs like 12 hours plus a day, right? And you're like, well, don't look like it, right? And you realize that like the chip evacuation is just so good on these like well-designed machines that like it doesn't look like you're actually using them when you open the door, and it's like, that's a good sign right there. Like that's what Haas should strive for. They end up spending a lot of time, like, just moving on to the next product, and their bread and butter is that thing. It's a Ford Taurus, it does its job amazing, but it's not a performer. And so that's the bummer, because for a lot of us, we've spent so much of our hard-earned money and worked so hard to get to this point. And it's like, yeah, it's not a Matsuura, but it's like, or, a German built machine, but like, this is what we got. And then to, spend $100,000+ on it and get it. And you're like, it floods your shop, and it's like, it's got problems, and it's like, it's hard, because $100,000 is $100,000, it's a lot of money.
So. Yeah, exactly. But so you also did the tool length, little ruler, more or less.
Yep.
Super cool. Great idea. I don't know how many times I've seen people just put a scale or something up to their tool and kind of fudge it up. But talk to me about getting things injection molded and going through the whole process of not only getting a patent on them, but finding suppliers and all that fun stuff.
Yeah, it all kind of fell into place. It was really random that it kind of happened. So I bought I came up with that tool like 6 years ago. Like, it's crazy sometimes when I look back at how many things like take me a long time, it's like, because I have so many projects going on, and like, and so like, that's one of the hardest parts. I feel like as I always have at least I went to school to be a chef, so like I'm used to cooking with like 10 things on the burner, right? And so like that's I feel like I'm pretty good at as being a chef. I can probably do 4 things on a burner. But like as a machinist, I feel like I can do like 35 pots, right? And so I'm like a lot better at machining than as a cook. And so I'm pretty good at managing all that stuff and making sure that I don't let some of it burn or, dry out. And so that was one of them. And it was mostly like, you put it on super low and you just wait until that moment comes up where it's the right time or the perfect opportunity comes, and like you can just make it happen. And so what that opportunity was, I came up with this. I went over to Autodesk. Arthur, who runs a lot of Pier 9, ended up printing one for me, and I tested it out. We printed on the object and clear so I could actually use it and check it and stuff. And it was like, I was like, this is pretty cool. But the first one was so huge. I gave it to my girlfriend and she was like, Jesus, that's huge, right? Like, she could barely hold this thing, right? Because I was like, what happens if you're putting like a 3-inch face mill in here? You're gonna want to see the whole thing, right? So it's like this like massive piece of plastic, and then it's like basically I was like, oh man, this is just too big. It's so thick, and I was like, I don't want it to ever break, and so what I did was I actually was like, this is the perfect opportunity. I'm gonna build this mold at some point or another. And so I actually started looking for an injection molder, and I went to this place that was doing all this work for Tesla. And Tesla was actually bringing a bunch of their injection molding in house and having other companies do it. And this company they were kind of just falling behind. And so Tesla decided to cut ties with them. So they had a bunch of these Arbergs there, and no one was there. Like the plastic industry, like for the most part in California is kind of dead just because the price of power is so expensive. There's
Mhm.
there's a bunch of really good molders here, but overall it's not something you can sustainably do here, paying 25 cents a kilowatt hour, right? Like when you can pay like 7 cents in Minnesota or, 10 or 5 in the Pacific Northwest, and so it's like so a lot of these molder people don't show up here to these auctions, and I get there and there's this Arberg there and no one's bidding on it. And it was awesome because it was like the classic scenario where like no one's bidding on it. And I looked out at the crowd and I said, no one bid on this. I want this. I guilt tripped the hell out of everyone. And it was crazy. It worked. I ended up getting the Arberg for like $2,000, and it was awesome because they started it at 10. And if you go to enough auctions, you realize that like, don't ever just raise your hand, right? If it starts at 10, just hang. Just it'll say 10,000, 10,000, 10,000. Just don't, even if they're trying to get you to start, don't. So then, you wait and they go to like 8,000 to get it going, 8,000, right? And they'll just keep working down. And so like, then after they get to like their second or third number that they've thrown out, you speak out and you say, I'll give you 2,000 for it. And usually the auctioneer will get mad at you, but they'll say, okay, I have a bid at 2, right? And so these are the secrets of auctioning, right? Like, and don't be that silly guy that bids right away. Like, don't be that person. And so I yell out 2,000 and the guy just looks at me like angry. And then I tell the crowd, no one's bidding on this. This is mine. And so then what I did is I ended up winning it, which that was like, they were pretty pissed about because it was basically like, it should have went to $35,000-$40,000. Like it was a super nice Arberg. It was like a 2007 or 8. So it's not that old, right?
Oh wow. Yeah.
And it came out of a shop that was basically doing medical parts, and it had it had both the plastic and the silicone injection set up in it. So it's like a pretty like, prized machine for doing medical parts, like a syringe with a double material. And so basically I get this machine, I go load it up. And so then I realized that like everything I designed with the ruler, the shot size was like way too big for it. Right? And so I started slimming it out and like got it thinner and thinner and thinner. And then it was crazy because like I had the molder, and then someone reached out to me on Instagram because I put a picture of it up, and they were like, oh man, we're looking for one of those. And I was like, oh man, that's awesome. Like, I was like, what do you want to offer? And he was like, I don't know, $20,000. I'm like, yup.
Sold.
As an $18,000 gain. And I literally still had it on the trailer. And so
Wow.
I literally just left it on the trailer and drove it down to LA. And I got there and I realized this guy had like a ton of skills doing injection mold. And I was like, here's the deal. Like, how about I give you this machine and you make the mold for this tool I designed and run this first production run of them, right? And he was like, hell yeah, deal, right? Because he knows he's going to spend like no time doing this. And I had everything figured out and like everything was ready to rock. And so basically I just traded him the machine for the tool and the first pilot run, which was like, basically 1,000 pieces. And he had just finished up a medical job he had basically a ton of expired by medical standards polycarbonate. And so he was like, I'll run all these out of polycarb. And they're like the super high grade medical, like optically clear stuff. So it was like, I got like, of course, the most, like if I have to buy them again, it's like too expensive. Now,
Oh man.
but either way, I got a lot of them for now. But yeah, and then so he did it, and like it turned out awesome. And so I would have never been able to do that level of work, and it worked out great. He got the machine he wanted, I got the mold, and then I found a company that did syringes for pad printing, and they actually print the pad. They made a pad for doing the metric and the standard rulers. And then, yeah, like it's really, other than that, the patent was pretty straightforward. It's kind of weird. There was like not any patents to really cite on like an optically clear ruler. So it was kind of strange to like basically look at it and be like, you can literally patent like an optically clear ruler and like sue everyone if you wanted. I don't know if
Wow.
it would pass in court because it's like, been produced for like the last 45 plus years,
Right. Yeah.
but it was just the idea of citing patents and stuff. And yeah, and so basically I found a patent attorney that was really cool and wanted to work with me. And he's really, really just stoked about having fun. And so he gave me a super good price. And so all in all, I'm like under $10,000 invested in this. And it was mostly a fun project to just kind of learn, and hopefully I can help other people out when they have questions or, sending people to the right people. And it was just fun, I think, if anything. And so those are available on cuttingtime.com. And I also designed a shop apron from all my years of like kind of wearing all these different aprons. I realized, the perfect geometry that I liked and kind of created that. And it's been selling as well. And so I have those made by a company that makes messenger bags. They make them for me. And
Awesome.
yeah, a whole bunch of stuff. So the goal is like you have that like backup, those products on a website. You don't think about them. You don't really do anything. Like maybe once a month you run another batch of them, but like it's just money coming in. It might not be a lot of money, but like a few $100 a day for not really doing anything, like profit is pretty rad. Like if I put a lot of effort into it and I really made a hard motivation to get out there and like market it, yeah, I can make way more money. But like I don't know. Like I also just like it's super neat, and I hope I can make someone else's machine and life a little bit easier. So I'm fine with not being greedy.
Yeah. Yeah. I think I think a lot of us want that kind of business where, it's not your get rich quick scheme, but it
Yep.
is like pays the bills, lets you into that world of making your own product, all that stuff.
It's been and it's a trial and error thing, right? So I've had many of these products, and some I've sold to other companies, and they're like produced now, and I've gotten a few provisional patents on things that like I've sold basically provisionals to people. And some of the stuff in the bike industry has gotten really popular, and it's kind of funny because like I've went down every path. I feel like I've like sold things away to companies. I've done it myself, and it's been such like a trial and error. And so like anyone, doing this, like don't be discouraged if it's not perfect, or it's like, I think there's always the optimistic thing that you're going to open your business and you're going to just get flooded, and they're like, sometimes this stuff takes time to get the momentum, and so it's just, hang in there and make sure everything else is all set up, like you're shipping and receiving. So you're not putting in any energy. Like the goal is everything that I do with this Cutting Time brand, I like put zero energy in. The only time I like put energy in is basically driving to the post office or, dealing with like the delivery of it. But like, I don't want to like it. The goal is that it doesn't distract me from anything. And like every month I get a few grand for just not thinking much, it's a
Yeah,
repayment for working hard before. So
totally. Yeah. Well, and like, I feel like if I had to go through the patent process, I'd be very hesitant. You're not hesitant to do it, but like there's just so many questions I would have. So it's cool that you've now gone through that. If you do have that, $1 million product idea,
yep.
now you know what goes into it, and you can just hit the ground running.
Yeah. And I think like it's, there's always going to be, no matter what, there's always going to be that like kind of question is like, is this should be patented? What's the right way to do it? And like, honestly, I mean, you can do a provisional patent for like $250, right? It's like, there's so many online resources now in the provisional, and that kind of gives you a little bit of leverage. It like allows you to put patent pending on stuff and stuff like that. And like, that does help, but like, it's tough. Like, for certain things, I don't patent things just because of the amount of time that it takes to do it. And it's also like, depending on how complex it is. So, people always want to patent something that's like I'm going to patent a bulldozer, right? And you're like, fuck, this is going to take like years to write this patent, right? Like, like every component ace basically needs to be cited in how it works and how it does this. And, it's similar to this. And it's like, so the simpler you make something, like the easier it is to get a patent. And there's design patents and there's, like that functional patents depending on what you're doing. And so, doing the design patents is actually quite easy to do them. But yeah, it's always going to be that. And so like for anyone that's like got a product that they feel like it's kind of up to you. It really also depends on how fast you're going to market it. So like, a good example is like Harbor Freight and stuff like, they like produce stuff at such a rapid rate and dump it into like society so fast that like by the time they get like cease and desist for copying and stuff like that, a lot of times they're like it's already made their money. And so you could do the same thing with a lot of your products. It's you're capable of it and you're able to, do the marketing and push it as hard as you can do it. Yeah, you can really make a lot of money really fast and you can get in there before everyone else starts to copy it. With the patent stuff, it's like, it's weird because you'll go through this phase where, you file the patent, you're like, okay, is it ready to release? Like, I don't know, like I've already put a lot of time into it and I'm already a lot of money into it. And like, is it perfect? And like, is this going to cover me? And like, in the end, you end up doing the exact same thing. You dump it out and you like try to rush to get it to people. And so it's kind of one of those things where like, I don't know, sometimes like it's really not worth it to go through the patent thing. Cause if someone's going to copy you, they're going to copy you regardless. So,
Right. Right. Yeah. Yeah. I've heard from a lot of people recently that at least I mean, like you said, it really depends on what you're doing, but like for a lot of smaller things, being first to market and kind of growing that audience around it makes a lot more sense for a lot of people than a patent.
yeah. And first to market also gives you some leverage on if something were to ever come up, like as long as you can prove that and the demand is there and everything, it gives you a lot of leverage to be able to be able to use that. So, I mean, I don't know. It's like for a lot of things, I like if you come up with something like, even for those sprayers, like I was like, oh, I know I can build a better sprayer, but like I could patent this or I could get a provisional. And so like in the end, like I'm just going to get them out there and sell them. Cause the other thing is like, I could patent it. And it's also like, if I patent it and I lock down this concept of certain things, I also like hinder people from also progressing. Right. So like, there's also like a part of me saying like, yeah, I'm making this right now to like provide people with a better service and better product for their houses. But like, I don't want to stop someone from making something better than me because like, really, these things need help. So like, I don't want to like be the hindrance of the guy that's like, you can't make a sprayer because I want to sell my like $40 sprayers. So
Right.
it's kind of like, I also like, there's certain parts of it that like, I'm okay with that. I'm okay with industry moving forward. I'm not that like clause into it that like, I feel like I need to own it.
That's awesome. Yeah. So let's run through some questions that Daryl sent in, NYDLS. He had some really, you know, highs and lows. What's the best lesson you learned in CNC so far?
Yeah, I mean, there's just so many varieties of lessons over the years. I'm trying to trying to remember one of the best ones. Basically, like there's like the one of the ones that makes kind of I'm in love with this industry. So like I like often think about it a lot, and I realize like kind of looking at it from job shop side, looking at it from products and building stuff, I kind of realized that like the most important thing to do is to like if you're a job shop, like focus on the industries you really like and love to be part of, right? And that will like your work will be like a perfect example of it. Your work will be better. You'll be happier. Like it's easier to work a lot more and be like way more stoked. Everyone's happier. Like, it's when you work on these projects that like you just, sometimes it's okay to make a little less money and know that like you got a little bit more freedom and you're like almost better energized for the next job that is more important, right? Like, if you're super into bicycles, like Joe like is a perfect good example of Cobra frames, right? Like, he probably doesn't make as much money as he would make if he was doing job shop work, but he really loves what he does and he likes being part of the industry and he loves the people of the industry. And so like you see it in his products and you see it in his podcasts and you see it in his videos that like he's stoked to like, be part of this industry and teach people and get, and it's like sometimes that means making a little less money, but like I think that's like one of the most important things is like making sure that you feel like what you're providing is a benefit to this industry that you love, whether it be like, energy or whether it be cars or, guns or whatever, that I think that's the major thing. I see so many people out there chase the money and they just get so unhappy with all the stuff they're doing and it just becomes so daunting. And I've seen some of the most amazing shops out there that are just in love with what they do, and everyone's so happy, and it's cool to see, like
Yeah,
Grismo, like he loves making knives, and like he makes great products, and he's happy to be there, and like it's an enjoyable thing to watch because you can see how much passion he has.
totally. Yeah, I completely agree. What's the biggest money maker you've had?
That injection molder, right?
Yeah, seriously. 1 day turnaround. That's
Yeah.
pretty good.
Yeah, I think like I think the biggest moneymaker. I don't know if there's really one on an example that comes to mind, but I think the biggest moneymaker is the one that you don't think the most about. It's the one where you get the job in from someone, you're stoked about working with these people. You like walk up to the machine, all the tools happen to be in there that you need. You walk over to the stock rack, there's like already a piece of bar that's exactly what you need. Like the vice is already set up. You just blast it out, you give it to the customer, and it's just like the customer's just like, what? You did that in like a day, And it's like that is like the best job ever. It's like so fulfilling and just like everything about it just makes you stoked and like makes you feel like so appreciated and enjoy your like craft way more. So that's definitely the biggest winner because it's not about like the money. It's about like also all the other stuff that goes with it.
Right. Yeah. Like I would say the biggest winners for me are the ones that are like the least amount of stress for the most amount of money. Like
Exactly.
not necessarily the most money outright, but like, yeah, we did these copper putter faces a while ago. And like, I think that they had expected them to be 3 ops,
Yeah.
like, because there was that, what used to be a big, I want to say face mill, but not face mill, fly cutter pattern in
Yeah.
them. And we ended up just 3D surfacing the entire angle into them and then just running a 3D trace with a chamfer mill up and down them. And it
Yep.
looked the exact same as a fly cutter would have, but they were 2 ops instead of 3, and they were super easy to set up and run. And it was like, oh man, I would do these again in a heartbeat.
Yeah, and you learn something, and like also it makes their product a little bit more distinct, and like I don't know, it just feels good to like also see them stoked about it. Like if they didn't like it, they can say it, and you'd be like, you know what, okay, cool, like I, you know what, I changed it up, but like But when someone's stoked like that, I mean, it's such a good feeling. And I think it's the same way with like the biggest loser is the one that like you're super bummed out about, right? And you're just dragging your feet and the customer's on your ass all the time. And like you cut the material an eighth inch short, and then like you get the end mill and the cutter like the flutes on it are an eighth inch too short too. And you got to order it and it gets lost. And then like MSC's dropping the ball. And it's like always something like that, and that's the biggest loser because you turn your like 5-second job into like, this like, 5-day job. So it's
Oh yeah.
kind of that's the biggest loser. It's such a bummer, in that, but it's part of the job. I think it's like, it's also the test, right? You can't always have the perfect journey to enjoy the destination.
Right. Right. So his other question was, how many customers, or have you had a customer where, paid really well, great money, but it was such a pain to run that you told them not to come back, or you fired that customer?
Yeah, I mean, there's definitely customers that, this happens, but like, you know what? I don't want to like also bum anyone out. And I never get to a point where I'm like, tell someone to kick rocks. Like, everyone says that stuff when they're not around. Right.
Right.
But like, I can never tell a customer that. So a lot of times what I'll do is like, it's something maybe I like spend too much time on. Right. And I was like struggling through it. And then because of that, I was late and maybe they were bummed out or whatever. So a lot of times what they'll do is they'll just be like, hey, there's a company in New Mexico that has this machine that is better for you to do this part on, and I'll like, I'm not afraid to like send work to the people that have the tools and expertise to do it. So all in all, I think it's like, I think it's like a soft way to like let them like, down. And honestly, sometimes it turns out better in their favor. Maybe they totally like that shop. Maybe they get a burned experience and realize that you're not as bad as they thought. It can work in so many different ways. And like, yeah, you might lose a customer, but like, what's the other option? You keep that customer around, you're bummed out, you're doing shit work for them, and like everything just sucks, right? Like makes your life miserable, makes their life miserable. It's just all in all, I think like it's safer to make sure that they succeed because in the long run, it will make you succeed.
Yeah. Oh, I do the exact same thing because there are plenty of parts that personally I see a bunch of red flags and then I give it over to somebody else and they're like, oh, that was the easiest job I've ever done. And it's like, you know what? I'm so glad that you could take care of it and
Yeah,
make money out of it because
exactly.
I know I would have been pulling my hair out for the next
And
3 weeks.
that's like some of the most important stuff is that you also find these people. Maybe they're not like your best friend, but the people that you work with, actually, I was thinking of one of the biggest gains for money was I do a lot of work for one of those online groups that, brings in jobs. I would not recommend any of those, but definitely like there was a point in time where like I was doing a lot of jobs through them in their early days of development. They're one of the San Francisco companies that does kind of the stuff like Proto Labs, but their algorithm screwed up. and basically they took in this job and I think like the metric thing screwed up. And so they were basically charging like $68 or something like that per part. And they needed 100 parts. And so I looked at these parts and I was like, wow, there's gotta be something wrong with this. So I accepted the job and it was like these like little 1 inch long pins. They were like kind of about the size of like a pen cartridge, but 1 inch long. And so like I sent it over to Tony, and Tony ran it on his Swiss machine. It took him like an hour and a half. And so I gave him $3,500 and I captured that. He was like, what? You giving me all this money? Everyone wins in that deal. And then who didn't win was the company that developed the algorithm for auto quoting, because they were super pissed and wanted the money back. And I refused to give them money. But yeah, those whole online systems, they're great for people that are like potentially unable to like round up some of the work, but it's hard. You got to be really careful you don't get sucked into their algorithm. It's similar to like how Lyft and Uber, kind of like they kind of pump the the pace of things for certain vendors. So certain ones get more and certain ones get less. And so you can burn a lot of energy that you should be putting into something else, trying to kind of cater to their needs. And so there's a lot of them out there now, and it's becoming a really popular thing to be the middleman. And so just a warning to a lot of the people out there that want to potentially join those kind of groups to make sure that you really, keep an eye on the financial side of it, because you'll realize you'll spend more energy and money trying to keep them happy than you will doing good work.
Yeah, I find that they're like the social media of manufacturing, where it takes work to make it work for you versus
Yep.
just getting sucked into it and like providing them content or providing them, what they want.
Yep. They're just a middleman. And like, I'm not going to say any of the names just because I don't know. I would hate to get attacked by one of
Blackballed.
them.
Yeah.
Yeah. But you know who they are,
Yeah.
and basically the problem with a lot of those systems too, is they're bringing in a good amount of money. So they charge a customer $500, and they look at this part, and then they say like, we'll give you 250 of it and then $50 for electropolish. And then they keep the 200 off the 300, and it's like, and they make more money usually than you do, and you're doing the work. And it's hard because then there's this middleman and you lose transparency. So if there is a problem, you have to go to them, and then they have to go to the customer. And, it just gets messy, and the timelines get shorter. You make more expenses buying stuff like, overnight shipping, and like, in a rush and freaking out about things and going custom cutter tools. And it's just, I warn people about it, because I'm worried that the industry is going in a way where that's becoming the new norm, because a lot of people are jumping into it to make that middleman money. And I'm worried that they're setting up a lot of shops to fail
Yeah.
on
I
certain
completely
aspects.
I completely agree. I think it's a great way to fill empty machine time, but
Yep.
like relying on it as your only source of income can get pretty dicey. Because like,
Yeah.
I'm happy to use this name because Make Time got bought out by Xometry.
Yep.
And like, if you were doing work with Make Time and doing good money there, like all of a sudden that might have dried up. But I
Changed.
mean,
Yeah.
I don't know. I didn't do any work for Make Time, but I could see how in a world of VCs and all of that, like those kind of companies could just change names or change owners and completely change
Yeah.
really quick.
Yeah, it's, and also there's a lot of people in the mix that don't understand like what it actually takes to do the things they're saying yes to. And so, that's a worry of mine, right? There's all these people that are like, it's easy, just do it. Right. But it's like, yeah, okay, you do it if it's that easy. So that's my take, as drifting off from, the biggest money I've made as also the biggest loser I've made. And I wish I could probably delete a last few years of that whole system from it sounded great until you get into it. So
Yeah. Yeah, for sure. So his last question was, what's the most gratifying shop to run through or job to run through the shop? Like, have you
uh,
machined any life-saving products or, anything that like just leaves you with that giant smile at the end of the day?
I think like all the things I'm like the most proud of are the things I never got, which is kind of the irony of it, right? Like I think it's just the compliment of being able to, even like, a good example is like when the Mars rover was having issues with the drill, like NASA sent me a whole print package of stuff to look at to help them like work on the drill. Like I didn't get that job, but man, I felt cool. And it's like, and like also, when the 2020 rover was getting built, I got like a ton of requests for quotes for like a bunch of the camera equipment, a bunch of the drill components, a bunch of the arm parts. And it was crazy because like, I don't know, it was like such a compliment to even be feeling like I'm at a level where someone would put that trust in me. And that was super cool. Like that, I probably wasn't qualified to do it. I know I probably could have done it. I don't think I would have done it as good as someone that probably got the job. But you know what I mean? Like, it's just the idea that like, man, I felt cool, you know? And yeah, I've built a lot of stuff over the years. And, all the stuff I do is pretty much science related. I really don't focus on anything like weapons related or generally for anything that's like heavy consumer products. I don't really, there's people out there that do that and love it. And I don't have anything against it. Just, those are just things that I don't kind of want to put any of my energy into. What I put my energy into is things that are super progressive and pretty much all science related. And some of the things I'm like the most stoked about right now are all the things I've been working on for good examples like flow batteries for, energy storage, kinetic flywheel storage. Some of the most exciting stuff I've been working on for the last 3 years is actually synthetic meats. So basically laboratory grown meats, chicken, fish, beef. And I've been really fortunate to be part of the design crew and also building all the prototype stuff for developing these laboratory grown meats. And I'm just like so stoked because these are things that like, we kind of bag on them right now, but they're like fundamentally like really important for people on Earth, but they're actually probably more fundamentally important for people that are going to be traveling in deep space. And so that's like some of that stuff gets me really excited, and really just anything energy related, I think is really important. I grew up in a power plant. My dad is a power plant specialist and a steam turbine specialist. And so to like really be part of energy is like something that's been my whole life. So yeah, I mean, there's just so many cool, wild projects and to see where things are going on like the neural implant stuff. So one of the other cool parts I do for a bunch of different companies, but one specifically is neural implants for people with Parkinson's
Oh,
too.
wow.
And so like I make a lot of the component stuff that basically helps with the manufacturing of these components of these implants. And so like these are, there's so many things like that. There's also a company that do design and build that developed basically a way to do a biopsy on your lung. It's like a snake that goes down into your lung and cuts out a small polyp of cancer and then brings it back out for a biopsy. And so like that's a pretty crazy project. And it's all built out of Nitronic, and it's wild because it's like, it's like basically a stainless snake, and it's got also the Da Vinci machine. So Intuitive Surgical, I do a lot of work for them. And to really be part of the Da Vinci, like just that concept of being able to surgically like work on someone robotically is like unbelievable. Like I'm like so proud of all the things that I'm like sitting here looking at my shelf right now of the last year. So basically every year I start a new shelf of stuff I've built, and I give, I put the extras on it, and I just look at like each year and I'm just like, wow, this is like, it's kind of surreal. Like quantum computers, the surgical stuff, a lot of satellite componentry, bicycle parts, stuff for Tesla, stuff for Neuralink. Like I just look at this like lineup and I'm just like, wow, these are all things that like, they might be total flunks, but you know what? It takes a few eggs to make an omelet. So sooner or later, you're going to have to break a few eggs. And
Yeah, totally.
yeah.
So you mentioned it. Joe from Cobra Frame Building asked, what the hell is a quantum computer anyway?
It's probably the most expensive and beautiful chandelier you can ever build. Yeah, it's like, I mean, I'm not even going to get into the science of it. There's enough information that's better told on YouTube about it. But man, making these parts is like, any of the listeners probably that work with copper really know the challenges that you can have with copper. And it sounds so easy and it's so soft and stuff. But like when you get into like really complex surface finishes, handling, the cleanliness of it, like just there's so much to copper that like we take for granted because like it just seems so soft and easy to work with. But that's only part of it, right? Like getting a part from the block of material to the customer and like perfect condition, no damages, no scuffs, no like mirror finishes on everything, ready for gold plating, like without any tarnishing. Like it's actually like it's a kind of a specialty thing. And like, people that cut copper a lot will probably know all the like problems you have. But and also just things like 101 copper, the oxygen free is a really sticky thing. So like you can't tap it like you know but you get so accustomed to working with aluminum all the time. It's just so easy. And then,
Yeah.
yeah,
Yeah. I was
you
going to
get
say
sucked.
drilling copper sucks. Like
Yeah. And
you would think like, oh, it's so soft. I can just ram a drill in there. And it's like, no, you will blow that thing up real quick.
yeah, and especially with the quantum stuff. So one of the interesting things about that is also anytime you make because you're dealing with things that are extreme cryogenics. So like you're like past cryogenics. Like there's only like 2 or 3 companies in the whole world that actually make components that can get you to the cryogenic levels that you need, which is insane, right? And the way they make cryogenics at that level is like a whole nother world that like is regarded in secrecy because it's like that there's only a few companies that can do it. And so what's interesting is you're at such a crazy state of both light and temperature for these things to work that like sealing needs to be perfect, like surface finishes need to be perfect. So you have like perfect contact points between two pieces of material. And so you build this thing and it's just like everything needs to go perfectly. Like your stacked up tolerances, you're using like triple aught zero, like screws on everything.
Oh,
Like your
geez.
big screws are like two dash 72s, or like, fours are pretty uncommon, but you're using a lot of little components. And so like, you start to develop all these strategies on how to do all this stuff. And then of course, like scientists will roll in and be like, we got this new material, right? Like that we want to cut. And you go on the internet and you can't even find anything on it, right? Because it's like, and yeah, like niobium is a pretty common one that a lot of scientists want to work with because of its properties. And like, working with niobium is like a combination of like copper, titanium, stainless, and bubble gum. And like,
Oh my goodness.
it's like everything about it sucks, right? It sucks to work with, it sucks to weld. And so like, it's just that like these exotics become such a common language too for these people that they're like, oh, we'll just do this and this and this, and so and also understanding things like prep for electron beam welding, surface quality finishes for needing for certain things. And so yeah, like building these things turns into a pretty involved process of very hands-on. And it's one of those projects where you can't just be like, I'm going to charge them per job, because that like every part that you make for them is going to come with like a whole list of information that you need to provide them with. That's
Oh
like
boy.
such an important thing to be able to provide your customers with that value added. And so you got to make sure that you're not just saying like it'll be $400, right? Because that like you're going to spend 3 hours prepping it and dealing with it, and also making notes for them saying like, hey, if you can do this and this and this, And so, but man, we're building this new system and it's going to the national lab, and they're putting in a whole power grid for that I've seen. They're like digging out the whole hillside to put in this like massive power grid because it's
Holy
using
cow.
so much power. But man, it's badass. Like search up quantum computers and you can watch like how it works, but it's a pretty amazing thing. And the use of it, actually, everyone's thinking about what they're going to use it for. But like the real thing is probably like, it's going to be for medical stock predictions and like probably weather stuff, because, you can compute things faster than anything using like massive data ranges. So
Yeah. Yeah, exactly. So the last question I want to get to is from Jeff at Akluma. And he asked, outside of machining, who is doing work that you're interested in?
I mean, lately I've really been into like, I've been really so sucked into like the idea of like mycelium and like things that are not like, like stuff that's growing in the ground, like mushrooms and stuff. And I think there's like so many industry paths right now that we're not looking at yet that I think a lot of machinists are going to benefit from. And hopefully, people can find people to partner with and make epic companies. Some of the wild things is like growing mushrooms for packaging. Like, I don't know if you've seen any of the mycelium growing packages. They basically, they cut like a UHMW plastic like template of the product, and then they grow the basically fungal network around the part, around the plastic part, and then
Mhm.
it creates a perfect cavity for the it's just like what they've been doing for foam for years, but it's natural, and you just throw it in your composter. And I'm like so intrigued by mushrooms and things like that, and trees just in general. And I'm so sucked into this lately. I don't know what and I think it's like also super important that you just kind of like look so many other places other than what you do to really see if there's a way that you can make a connection, with
Yeah.
or something.
Well, and I think that's something you talked about last time you were on, is that you have kind of built your career around absorbing all of this information from a wide variety of sources and being able to synthesize that into solutions.
Yep. Yeah, I mean, connecting the dots, like knowing who to talk to, and like the network is the key part of it, and knowing that like this person's doing this and you should talk to this person. And it's like, man, that's the best part. Doing the work is cool, but man, meeting the people is sometimes the wildest part of it. And I meet these people, I'm just like, man, this person is so weird.
Yeah, I think that that's like a super cool part of being in this industry, is like being able to talk to such a wide variety of both interesting and strange people. And like, I just love talking to somebody who is so passionate about such a particular thing. And
Yeah.
like that seems to be the coolest part of this, is like you get to meet all of these scientists and researchers that are just like so into the nitty gritty on their thing.
Yep. I mean, one of the craziest places, it's like, working for Elon and working for Neuralink, like being around the best brain, like researchers in the whole entire world, like when you're Elon, you get to pick the best people, and like, and then, being around those people and just seeing the level of dedication and understanding and everything. And then working for the nuclear people and like seeing people that have dedicated their lives to this like industry of knowing this, like it, and like nuclear, and like nuclear is about as like weird as like, I mean, they're all so different, but they like, I think what comes back to this commonality is there's so many unknowns. So it's like space travel, so unknown. We're just so deep out there, like you don't even know. And working with the brain is like just as crazy as space. Like you just don't know where it's going to end. And then you go to like, working with nuclear, and it's like, no matter what thing you can think of, there's always something else that will happen, and it's like, it's crazy because you're working with this neutronics of things that like you can't see or do or manipulate in certain ways. And so it's wild, like to be around people that like are as smart as they are and still like they still hit the end of where, like they're understanding. Like it's a trip. And like I love it. I love going to NASA. I love talking to people that specialize in specific things. And I feel like that's like what makes my job also the best, is just being able to talk to those people. And then I can also be like, it would be super crazy test to try. Right. And then like get them all amped up. Right? Next thing you know, you're like building parts for them, and you're like helping with their research studies. And like, I've worked on a telescope exactly that way. And now it's down on the mountaintop in Chile, like looking for the origins, the Big Bang out in the universe, and it's like that started from me just like kind of just picking someone's brain. And then next thing you know, I'm like spending months building a telescope. Like
Yeah, that's pretty
I was
amazing.
like that. And I think that's all, like, there's so many amazing people in everywhere. You don't just need to be in a specific place. Like, and there's a lot of people out there that have amazing ideas that like just don't have that way. Like that they don't have maybe a mechanical background to like really know how to bring it to life. And so, a lot of people that listen to this have had scenarios where they're like, I know this happened, and I was able to help this person. And it's like, that's it. The more people you communicate with and like, pick people's brains, the more opportunities will come.
For sure. Oh yeah. So that brings us to shop news, new things. You, just before we started talking, said you brought another DT in house. So what's going on with, I guess it's not MLS anymore, or?
Oh, I mean, it's always MLS. So will always
Good.
be my heart. But
Good.
yeah, so for cutting time, I brought in a bunch of new equipment, and so I've got another little 5-axis DT1, but I bought this one kind of in a pinch because I had a job that was like, this is perfect machine to put on it for making crop sprayers and drone crop spraying airplanes. And I was like, I'm just going to let this stuff run on it and making parts. And it like shows up on the truck. And, and of course, like, first of all, like we have to get it off the truck and I do all my own rigging because I love doing it. And like we got like a level 10 boss, Karen, that wants to just explode on us because like she basically like we blocked the street for now over 30 seconds. And so then like that is how it started. And then we unloaded and I kind of bought it sight unseen. And then I like untarp it and look at it. And there's like, it's the most dense from the inside of a machine I've ever seen.
Oh no.
It's like a golf ball, but reversed. Like if you flip the golf ball inside out.
So they were just throwing parts like crazy
They're
or
all
something.
different. They're all different dents, which is weird. It's like one's clearly a vice, but one's like clearly a part, and this one looks like it's a cutter. Like,
Oh my
we
goodness.
counted like 10 plus dents just like from the inside out. Like, it's amazing, but like it runs good. It's just definitely like, yeah. And so I got that one going. So I have two little DT1s and they both have scales and stuff on them. And so I use them for like a lot of the little medical parts that I make. And then just recently I figured out that I'm actually getting a Matsura 330. So that is going to become the new bread and butter of the operation. And then hopefully we can build some really cool titanium aerospace parts on it. So
Hell yeah. That is fantastic.
Yeah, long story short, it got a little damaged, but it's, you know what? It's all been checked out and approved and like, yeah, so it's all good. I can live with that, you know?
Yeah. Well, and I'm sure you'll know how to rig it correctly into your shop.
Yeah, it's going to be a pretty epic machine. And I like a lot of it was just getting it for the quantum computers. And it really like allows me to kind of step into a different world of precision that I wasn't able to get with like, even though my little machines, my little DT1s have scales and they're super precise and like the parts I'm making, you know, they don't need heavy load on the cutting. It's just, you know, that machine is just so much more capable. I'm going to be super excited about it.
Yeah, that's awesome. When's that supposed to land?
So it's already ready to be brought in. I just need to move my whole shop around. And so I was finishing up the last job yesterday. So hopefully in the next like week or two, I'm hoping that I can get everything moved around. As soon as the DT1 showed up, that machine became available. I was like, damn it. Of course. I feel kind of bad because now I've like spent all my money.
It was funny. I saw a DT1 with a TRT on eBay recently, and I was like, "Oh, I wonder if Jeff's selling his." But it was like in Ohio or something, and I was like, "Well, it's not him." But
I was gonna build the little UMC 250, but I started laying it all out, and I took a bunch of stuff apart, and I realized that like it was like perfect for doing parts that were like it was. The problem is, like when I put the trunnion on the x-axis, the tool changer, the like, because you know the DT1's on like on a spool, like, and it hangs pretty low, so it actually like the spool of tools kind of hangs below because the tools they don't go horizontal with the x-axis like they do on like a VF where they turn 90 degrees when they get pulled out.
Right, it's just always 90.
They always stay straight out.
Yeah.
And so what I was running into problems with was basically the trunnion height gearbox and all that stuff when I was trying to like build this mini UMC 250. And so basically what I did was I just put that trunnion on the other machine and I just put it in the y-axis direction. And then I just shortened up the servo drive range on the max travel. And so now it fits. It's perfect. It actually makes really good parts. I seen it on Haas's website. They don't want you to put it on it, but I seen that there was a medical company that did it, and I was like, it's possible. So then I copied it, and it like worked, and it's awesome. I just cut titanium parts all day, and it's so perfect. And I got also it's pretty new, but what's really good if you don't have the budget, this is kind of I run like a shoestring budget basically because I always want money to build cool stuff for myself. So like I don't try to spend as much money as possible, but I needed a speeder for doing high speed machining, but I couldn't afford like an air turbine, right?
Mhm.
And because they're like $6,500 or whatever. And then also can't do a tool change very easily on those machines because they're big and clunky. So I found they're the new German company. It's called like Trolley or something like that. They sold the rights to their product to DWO, the live
Oh, the
tool
little
company.
coolant spindle one or the coolant
Yeah.
through ones. Yeah.
Dude, I just did a titanium job and I was using a 10,000 end mill for like days and it held up and it's awesome. So I got through coolant on it. I got the 1,000 PSI and man, that thing spins at 80,000 RPM and it just cut.
It works pretty well.
Yeah, it's so weird though. Like when you buy it, you're just like, nah. Like it shows up and it's like basically like two bearings and a piece of plastic that looks like a little turbine, and then like a press tool, and you basically press the end mill into the plastic little turbine part. So the only way the end mill's being held is this little plastic part that it's pressed into, and it just seems everything wrong about it. You know what I mean? Like because it just seems weird that you'd press it into the plastic, but then running it's awesome. Like I'm sure people in certain applications, it's probably not the right tool for the job, but for doing like little end milling and stuff like that, it was pretty epic. Like I just did probably close to 45 hours. No, more than that, probably like 70, 80 hours on it this last month. And I went through 3 end mills. It was the run out was awesome on it. And I was running 30,000 end mills in it and it lasted like hours and hours. It broke on my last part. I was like, I can live with that. So,
That's amazing.
yeah. So, and it's under $1,000. So it's like, definitely if you're having problems with like small parts and you need that and you have through coolant, like it's definitely something you should definitely look at because it was the best bang for the buck.
Huh. I'll definitely have to check it out because I talked to somebody who was using it, but I think they were trying to slot a heat sink with it, and it just like had some weird run out issues and not enough torque. It sounded like, but it sounds like it's more for real tiny end mills, maybe 3D surfacing or something like that.
Yeah, I mean, I was doing like 5,000 on the step down, and basically like doing a full slot depth on with this 30,000 end mill. And so it's not like super deep, right? And I did over 1/8 of an inch deep on the slot and just back and forth passes. And it was going about 50 inches a minute. And like it took my cycle time when I didn't have it, which was about 4.5 hours to do those slots. It took it down to about 47 minutes.
Wow.
So it was like night and day difference. Yeah. I mean, other than the fact that I hate listening to my like through coolant pump run all day because again, Haas is like, how can we save money on this high pressure coolant system? I got it. We'll just use a pressure washer from car pressure washer.
That's what I've got on the Speedio. And yeah, it's pretty loud.
Yeah. It's again a way to cut corners. So
well, cool. That kind of wraps up the episode to the last question I ask every guest, which is, what did you research this week? So besides mycelium packaging and all the other crazy awesome things you've mentioned, is there anything else you've been researching?
No, just having fun mostly. Just trying to wrap up everything and get ready to party.
Heck
Friday.
Yeah. And you gotta move your whole shop, which I just did last week, and it's not a lot of fun.
Yeah, I was stoked to see you got a replacement for that machine. I seen the old one go out and I was like, and then I sent you a message. I said, you getting the new one in? And then you're like, yup.
Yeah. I think we just decided like the same day. I was like, I'll reach out to my salesman and see if they have any demo machines. And he was like, you know what? We actually do.
That's awesome.
I was like, all right, well, time to party then.
Yep. Sweet. Well, right on.
Yeah, well, to wrap up the episode real quick, couple of Patreon thank yous. James, Dustin, Charlie Lewis, and Chris Brown, thank you guys for backing the Patreon. Helps
party
me.
Time.
Yeah, exactly. Helps me keep the party going. I just had to upgrade my hard drive because storing all this high quality audio, it takes up a lot more room than I thought it would. And so, Patreon helps out with that stuff. And yeah, it's great. Jeff, real quick, where can they find you and Cutting Time and all that? plug your stuff.
Yeah, cuttingtime.com, global empire, monkey like shiny, the world's largest company. Right below it is Google. And we pretty much are going for total world domination, and we're nowhere close. So it's Coors time.
There you go. So yeah, go to Cutting Time, guys. Go buy, if you got a Haas, buy all his stuff. Buy shop, apron, all that stuff. Thank you again, Jeff, for coming back on. We'll have to make this, a once every couple of months kind of thing, because there is always something cool to be talking about.
Also, I like maybe if we do it more commonly, then they don't turn into like 4.5 hour long episodes.
Yeah, exactly. All right. Well, I'll ping you every couple of months, and we'll have you back on.
Perfect.
And next time I'll just send you a mic so that we don't deal with your Bose headphones.
Come on.
Bouncing around.
Awesome. Thanks a ton.
Yeah, thanks. And thanks everyone for listening. We'll be back next week.